Hello again and welcome back. Here we are, class 4, learning the Swift language, and I have one last thing to say about structs before we move on to classes. So structs, or actually the data types that you saw originally, string, double, bool, array, and dictionary, are actually represented as structs in Swift internally. So, think about that for a minute. When you use a data type like array, you access its properties. So these are implemented as variables within the structure. And count is an example, right? So when we do array.count, it tells us how many items are in the array. And that variable is maybe updated when we add a new item to an array or remove an item. And then arrays also have methods. So when you add a new item to an array, you call on one of the array methods, and those are implemented inside the struct that represents array or defines array. Okay, so with that out of the way, let's move on and talk about classes. So classes are a lot like struct. Okay, so instead of using the keyword struct, we use the keyword class. Classes have a few other features that structs don't have, so there's a couple differences. And we'll get more into that later, but for right now, we can actually just look at them as being almost the same, right? You'll see here I have a class called customer, and it implements a first name and a last name, and then it has an init method. Structs can also have an init method, but you get it'll initialize the properties for free. Like, you don't actually have to write the initializer yourself if you don't do any other code besides initializing the variables. Okay. The initializer is a special function. So you can see we kind of wrote this like a function, but it just says init and it doesn't have the keyword func in front of it. And you can think about the initializer as the code that's run when the item is created. So when you create an instance of a customer, you call on the initializer, and then any code here is run, okay? And from outside the class, when you call on customer here to create or initialize a new instance of customer, you can think about this as calling the initializer, right? So you can see here I've got, customer, and then it says first name and last name. And up here, I've got init, and it says first name string, last name string, right? So so that's basically how to create a class in Swift, right? Let's experiment with that, right? So what I'd like you to do is create a cashier class, right? And we're going to use the customer class later too. So you can copy the customer class into your playground that you're using. So maybe I'll do that here. So I'll just paste it in like this, and now I have my customer class, okay? Usually we define classes and structs like in their own file. So you just have one file that's responsible for that, and then you can import it into other files. But for the playground, we can just put it all in the same place. And we can use this customer class as a model for creating the cashier class. So let's look at the cashier class. So our cashier class is going to be called cashier. By convention, we name classes with an uppercase letter. It'll have a first name and last name property and a has bathroom key property. So first name and last name will be a string, and has bathroom key will be a bool, okay? So let's give this a try. And what we're going to do is we're going to initialize it in the initializer, right? So we're going to use the init method, okay? So let's take a look. So we'll start here, we'll say class, and then we'll say cashier, and then use the curly brackets, right? So this is our class, okay? Everything within the curly brackets or the code block is part of that class. Next, I'm going to set up a first name property and a last name property. These will both be strings. And then I'll add the new property, has bathroom key. And this is going to be a var because people lose the bathroom key. So, so this property has to change at some point, right? So we'll say has bathroom key, and then it will be a bool. Next, we'll set up our initializer. So there's the initializer there. So we write it like a function, but we don't have to put init on it, okay? And then I'm getting a warning here because it says return from initializer without initializing stored properties. So these are my stored properties and they haven't been assigned a value. So I need to assign them a value inside the initializer. If I don't, then I'll see an error. Okay, so my properties here, when I initialize, I'll give my initializer some parameters, right? So I'll say string, and last name will be string, and has bathroom key will be a bool. Okay, and now I need to initialize these properties. Now I'm in a weird situation because the parameter variables here that you're passing into this initializer function, right, have the same names as the properties for the class, right? So it kind of seems like they're the same thing, but they're actually not. These are totally different variables than the variables that you have here. And that's a problem for the computer because, you know, if I said first name here, it doesn't know if I'm talking about this first name or this one. In this case, we could do one of two things. If we rename the variables here to use different names, then the names would be different and we would be okay, right? So I could just call this first, and then I could say first name. You notice it turns kind of blue-green, right? And I could say that equals, you know, first, and this one's white or light gray and it looks like this, right? Okay, but let's imagine like I don't want to do that because it's kind of nice. I know that this is the name of the parameter that matches this one, right? Like they go together. So in that case, what we can do, and you can see here actually, look at the color coding. So this one is kind of the white or light gray. So it's telling me that it is the property here. So the computer sees this as the property that's coming in here. It doesn't see it as this one. And the reason for that is these variables that are passed in as parameters, they override the variables that are outside. So if they have the same name, then this outer variable is not accessible within this block because it has a parameter with the same name, okay? So to solve this, we're going to use the special word self. So if we use the keyword self here, what we're saying is you know, this class, right? Self is like my instance of the class. So if I say self.firstName, it's like this variable that belongs to the class. Actually, I spelled that lowercase. Should be uppercase, right? So this is self is saying like the variables that belong to the class. So now I can say, you know, first name local variable self.lastName equals local variable last name. Now watch when I type self and I hit the dot, you'll see a list of all the properties that belong to the Cashier class, right? So Swift sees that when you're using the self keyword and you hit the dot, you can only access all the members of that class, which would be its properties and its methods, right? So there we go. So now our class is initialized, Cashier, right? Let's make an instance of Cashier. So let's say, let Cindy equal Cashier, right? I'm just doing alphabetical names. So I did Andy, Bobby, and now I'm on Cindy, right? And then here you can see I've got Cashier, and if I hit the parentheses, it gives me the properties for the initializer, right? So we'll say first name is, Cindy. Actually, and if you're here, you have these highlighted values there that you need to fill in. You can hit the tab key to go from one to the next. So let's do last name of Jones and has bathroom key of true, right? So that works, right? No, we've got a new Cashier. So let's imagine something else. So, you know, maybe every Cashier, when they're created, they automatically get a bathroom key. So for fun, what we could do is we could give has bathroom key a default property of true, right? So that means that if you don't include the has bathroom key property, the value will be true, right? So if I don't include this property here, then when we call on the initializer, this has bathroom key will have a value of true, okay? Now watch how the, let's say Dan here, we're going alphabetical, right? So let's say we get the cashier again, we're gonna initialize a cashier. Notice it gives me two ways to initialize this. I can initialize with first name, last name, or I can initialize with first name, last name, and has bathroom key, right? So if I want to set the has bathroom key, I can do that, or I can leave that out, and then Swift sees that that has a default value, so it's not needed, okay? So I can initialize Dan here as Dan, how about Dan Smith? And there we go. So now we've created our class, okay? So let's take a look at the next problem here, right? And again, actually, let me go back there one more time. So if you wanted to print any of these values here, we could say like Cindy dot first name. I can say print Dan dot last name, you know, and run that code. So I got to open up my terminal here. And then I get the two names, right? So otherwise, you know, essentially an instance of the class acts the same as an instance of a struct, right? So we can access its properties with a dot. We can add variables to it. We can add methods. Structs, I didn't do an example of struct with an initializer, but a struct can also have an init method, and it would look the same as this. So yeah, so they're very much this. They're very similar, right? We'll get into some of the differences later, and the big difference is reference versus value, right? So let's move on to the next slide. Okay, challenge number 4. So this is your challenge here. Add the customer class, right, from our example earlier, right, and factor it into your playground, right? So, you know, it says, you know, using the class to represent the customer instead of the string for the name. So you can see in our code here, we have an order class, and when somebody takes an order, they include their name. But what I'd like to do is I'd like to put a customer object here in this place. Okay, so I'd like to use the customer here. That'll mean that down here, when you create an order, you'll have to kind of change the way that this works, because you'll have to create a customer, right? And then pass that in your order when you call on order and create a new instance of order, okay? Okay, great. So why don't you give that a try, and then I'll walk through a solution in the next video.